Welcome again, everyone. There are handouts being handed out, which I hope most of you have. There's some gentlemen over here with their hands up, so can you bring this back to them, please? So try to snag a copy of the handout as it goes by. This is CS61B, Data Structures and Advanced Programming. I'm Jonathan Shewchuk. My last name is pronounced Shewchuk. My email is jrs@corey.eaks.berkeley.edu. However, for the vast majority of questions you'll ask in this class, you should really send your email to cs61b@corey.eaks. And the reason you should send it there is because email sent there goes to me and all the TAs, and you'll probably get a faster answer that way. There are reading assignments most days, but I'm only going to tell you today's reading assignment. In the future, you're responsible for keeping up with and knowing your own reading assignments, all of which appear on the class webpage. One of the first things you should do after this lecture is go to the class webpage, visit it, familiarize yourself with what's there. In particular, familiarize yourself with when the midterm and final exams are. They are already planned out, and we want you to be there and show up on time, and they're very unlikely to change. There's also a class news group, and you should consider this news group to be required reading. If you don't know how to read a news group, well, you'll learn about it in your first lab. The news group is ucb.class.cs61b. Now, this class has labs and discussion sections. The labs are in 275 Soda. Telebears, or the university databases, say 277 Soda. They are lying. It's actually next door in 275 Soda. They start next week. The labs are on Tuesdays and Wednesdays, but there won't be a lab tomorrow or this Wednesday. They start 8 days from today. But discussion sections do start this week. Discussion sections are Thursdays and Fridays. Now, you are expected to attend the lab that you're registered in because there's a very limited number of seats and computers in the labs, and so it's very important that you go to the lab you're registered in. You can't get checked off by going to the wrong lab. So please attend your scheduled lab. And your scheduled lab only. Now, some of you do not have a scheduled lab yet because either you're on the waiting list. If you're on the waiting list for the class, it is probably because you're on the waiting list for a particular lab that has too many people. So your choices are to either switch into a lab that has spaces or wait a week or two and hope that other people drop out of the lab you want. Also, some of you might want to enroll through concurrent enrollment. If you're a concurrent enrollment student, then first of all, just bring me your paper to grant permission for concurrent enrollment, and I will sign it. Anyone who wants into the course gets in, as far as I'm concerned, as long as they have the prerequisites. Also, you don't have a scheduled lab if you're a concurrent enrollment student. For those of you who do not have a scheduled lab, what you should do is just go to any lab that has room for you. And that means you go to a lab, you ask the TA if they have room to take you on. And if they say no, then you have to go to another lab, so you might not want to try this on the very last lab of the week first. Hopefully, after the first 3 or 4 weeks, things will smooth out a bit, and a few students will drop, and everyone will get into the lab that they want, or at least a pretty good lab. You will need to go to the lab to get your class account. You will definitely want to log in during the first lab so that you can get a grade. Let's see. All right, prerequisites. just so you all know, the prerequisites for this class are CS61A or E77, I think it's N, but I might have the letter wrong. If you have not taken one of these two classes, the registrar might have allowed you to enroll in this class, but you'll probably eventually be dropped from it anyway by an automatic computer program that drops you if you don't have the prereqs. There is one exception to that, which is if you believe you have taken a class similar to one of these two classes somewhere else at another college, and you can convince the right person of that, then you can appeal. And you can get appeal forms from 393 Soda Hall. Also, if you've taken a data structures class before at another university, you may be able to skip this class. And if you want to find out more about that, the person you should talk to is Brian Harvey in 781 Soda. I'm not going to write this down, but it will be in the lecture notes, which will be on the class webpage by tomorrow. Let me introduce you to the textbooks for this class. There's two of them. For the first month or so, we're going to be learning the Java language out of this book called Head First Java by Kathy Sierra and Bert Bates. I like this book a lot. I picked it partly because it's cheap compared to most textbooks, and partly because it's really good. It's one of the best Java books I've seen, so I hope you'll like it. The other book is called Data Structures and Algorithms in Java. It's by Michael Goodrich and Roberto Tomasia. This book is what we will learn data structures out of, which is the central part of this course and my favorite part of the course. Unfortunately, a lot of students have said they don't really like this book very much, but I can't find any data structures book that everybody does like. There doesn't seem to be a really good one out there yet. So some of you might be able to get away with not buying this book, but I do think these guys deserve the money. They did a good job. Now, this is the second edition of Head First Java. If you buy the first edition, it's just as good as the second edition. There's nothing in the second edition that you need that's not in the first. So you can get away with the first edition. The only thing is that the class readings that are on the class webpage refer to the new edition, so they'll be off a few pages for the old edition, and you'll have to figure out what the correspondence is. Now, for this book, Data Structures and Algorithms in Java, you can also get away with using the first or third editions, but the second edition is missing two important data structures that we're going to learn in this class, so I don't recommend the second edition. Again, if you get an older edition, you're going to have the same problem that the chapters won't match up, but you'll probably be able to figure out from the names of the data structures which chapters to read here. There is another thing you should purchase as well. This is the class reader. It's the CS61B class reader. It costs under $10. Most of this class reader is old midterms from data structures when I taught it. So it will give you the very best study guide you could possibly have for my exams. And these exams are not going to be made available electronically or in any other form. So if you want them, buy the reader. There are solutions to the exams in the reader. The solutions are online. So you can find those online, but not the exams themselves. So that comes highly recommended. Oh, it has a few other things in it worth noting, like there's an Emacs quick reference card in the front and instructions on the Java compiler and Emacs and stuff. So this is really handy to have right next to you in the lab while you're working on your homeworks or your labs. And the reader is available in Copy Central. One location only, as far as I know, the one on Hearst Avenue. And that's a block from Soda Hall where your labs are, so you're going to be heading that direction often enough anyway. Let's talk about grading. Everyone always likes to know where their points are coming from. This is where your points are coming from. There are 200 points assigned total to all of the work that you do. And yeah, this is listed in the reader, but just as a quick overview, those 200 points will come to you as follows. There will be 10 points for your lab work. There will be 20 for your homework. There will be 70 for your projects. As you can see, the projects are a very big deal in this class. There will be 3 of them. That's half the points. The other 100 points come from the exams. So midterm 1 is 1/8 of your grade. Midterm 2 is 1/8 of your grade. And the final exam is 1/4 of your grade. And that adds up to 200 points. And the grading scale is that if you get 185 or above out of 200, then you get an A+. If you get just under 185, but over 175, you get an A. And it continues downward in 10-point increments all the way down to D-, and then if you don't manage a D-, you fail. So there's actually a chart in your course overview that you've been handed out that will map all of the grades for you. Question back there. Do I have any extra handouts? Not up here. Were there handouts left? One over there? Thank you. We've got too many people who want them, so. Excuse me. Who was the original person who asked? You were. Okay. Afraid we're out of them for the rest of you. They are on the class webpage. You can download and print one from here. I apologize for underestimating the number of people who'd show up. I want to talk a little bit about cheating in this class. There's a few important things you should know about cheating. One is that cheating, when it's caught, which it usually is penalized, and one of the things that happens is that you have your cheating reported to the Office of Student Conduct, and they keep a permanent record of what you've done for the rest of your college career. The other thing about cheating that's well worth knowing is that if you do something like cheat on an assignment that's worth 30 points, then you will get minus 30 out of 30, which means you'll have to do your other projects just to catch up to 0. What constitutes cheating, you might wonder. The most important thing in this class is what I call the no-code rule. And there are 2 aspects to this. One is you never give a copy, never have someone else's program or Java code in your possession at any time. And that includes reading it off of their screen. The other aspect is that if you give your code to someone else, even if they give you the assurance that they're not going to, steal your code, you're still cheating, and if you get caught doing that, then you can lose the same way. Never let anyone else see any substantial amount of your code. These are the most important rules. I think most of you know what constitutes cheating on a midterm and stuff like that. Other types of interactions, when you're not doing a midterm and you're just doing computer programming homeworks and labs in this class for the most part, we consider it acceptable for you to talk to each other about the homeworks, about the labs, how you did them, how you solved certain problems, as long as your talk is not in the form of sharing code. So it's not wrong to talk about how you approach a programming task, but you have to be the one to program it yourself, and so does everybody else. Is there any questions about any of this so far? Yeah?
Will we ever have projects where we have to work on code together, and will we have to show which parts we did and which parts are part
Thank you. I'm glad you reminded me of that. I almost forgot to tell you. So, group projects. The projects break down like this. Project 1 will be an individual project. Projects 2 and 3 will be group projects. And for the group projects, you must work in a group of 2 to 3 people. You're not allowed to do them individually. But we're not going to have a huge amount of oversight of who does what. For the most part, it's like the military. You and your squadron live or die together. But, you know, if they're a hoser, you lose too, I'm afraid. So watch your group members. But on group 2, we will have one mechanism where you do, when you submit your project, tell us who did what. And that's mainly used to resolve certain violent disputes that sometimes come up among groups. So your grade probably won't depend on that, but there is a place to at least note if your partner stabbed you in the back somehow. All right. Here's what we hope to accomplish for you this semester. First of all, you'll learn how to program data structures and make them run efficiently, which means a whole lot faster than if you'd done them the naive way, and algorithms that operate on those data structures. You will design and write large programs. Much larger than the programs you wrote in CS61A. And when you get to the team project, especially project 2, it'll be really big. You'll probably not understand this sentence yet because you don't have the terminology for it. But you'll be understanding and designing data abstraction and interfaces. And it will take me an entire semester to make you understand what this means and why it's important. But it's very important. You'll also learn Java, which is handy. Not only is it used a lot in industry, but it's a good language for learning data structures in, because I find that compared to languages like C, it only takes half as long to debug your program and get it working. It catches a lot of errors for you. I want to introduce you to the language of object-oriented programming. Because Java is an object-oriented language, and we'll learn a lot about how that works. Now, probably not everything I write down will make sense to you right now, but I'll try to give you sort of a bird's eye view, and later on in the semester, these things will become concrete as you learn them. So, first of all, what's an object? It's a very simple idea. An object is a repository of data. Like, for instance, you could have a shopping list object. Let me draw one. There's a repository of data. The data encoded upon it is that I need to buy milk and jam. And this particular object has a name. I call it my list. And my list is an object. And it not only is it an object, but it's a particular class of object. It is an object of class shopping list. And so that's how my computer can store my shopping list. Which brings me to the next definition. What's a class? A class is just a type of object. I can have many different types of objects. I can have shopping lists and I can have shopping carts. And putting milk on my shopping list is very different than putting milk into my shopping cart. We also have what are called methods. What's a method? A method is a procedure or function that operates on a particular class of objects. Well, it usually operates on a particular object, but sometimes you can have methods that operate on a whole class. You'll understand what that means later in the semester. Now, if you've used a language like C or Pascal or BASIC, where you've worked with procedures or functions, methods aren't really that different. I think the people who invented object-oriented languages decided to rename them methods because they were arrogant and felt a new name would glorify them. Object-oriented languages usually have something called inheritance, which means that a class can inherit properties from another class, from a more general class. For example, the shopping list class inherits from a more general class called list the property of storing a sequence of items. Getting into the stranger and harder to understand ideas, there's something called polymorphism. Which your textbook talks about in great depth. Polymorphism means that one sort of method call can work on several different classes of objects even if the classes need different implementations of the same method. So, to give you an idea of what that might mean, I might have a method called addItem that works on every kind of list. Including shopping lists and shopping carts, even though adding an item to a shopping list is very different than adding an item to a shopping cart. I know that's a bit of a cryptic definition and it probably won't make too much sense to you now. But the main thing I want to point out is that polymorphism is really the thing that distinguishes object-oriented languages in a big way from other procedural languages like C and Fortran and BASIC and Pascal. And so we'll spend a lot of time on it later in the semester. And finally, what does object-oriented mean? Well, here's what's a little bit weird, is that in an object-oriented language, each object knows its own class. And knows which methods and which method implementations work on that particular class. And so each shopping list and each shopping cart knows which add item method it uses. And so if you call add item on an object, you don't have to know whether the object is a shopping list or a shopping cart. The object knows and figures out which add item method to call for you. Any questions about this? Yeah. That's right. There's a process called dynamic method lookup by which the Java interpreter figures out which add item to call. Mm-hmm. Yes? No, operator overloading and dynamic method lookup are two different things. Operator overloading is done by the compiler at compile time, usually. Well, yeah. Okay, let's look at a little bit of Java. Let's look at a few lines of actual code. First of all, we want some classes to play with, and there are two ways to get classes to play with. One is you can use one defined by someone else. And Java has tons of these in what's called the Java Standard Library. And the second way is to define one yourself, which we'll learn how to do in a lecture or two. But right now, let's just go with option number one. We are going to use a built-in Java class called string. And first thing you need to know is that in Java, you must declare any variable before you can use it. Now, this was not true in Scheme or MATLAB, which most of you have sort of cut your teeth on. These things are so sticky. So, here's a line of code that declares a variable so that you can use it. Okay, this declares a new variable called myString and declares that the class of that variable is string. So you can use it to store strings. So what happens is that the Java compiler creates for you a little box in memory called myString. And that's your new name by which you will refer to that variable evermore. Now, this is a variable. It is not an object. There is no actual string object here yet. But we can create one now that we have a variable and we know what its type is, namely string, we can create a brand new string object and assign it to the variable myString. And so what this does is this line of code here does two distinct things. First of all, this new string stuff is called a constructor. It actually constructs a brand new string out of thin air, string object. And secondly, the assignment statement causes myString to reference the object. So remember that word, reference. And the way we show that, now we have our variable myString, and it's pointing at this string object here. So there's your first 2 lines of Java code. There'll be lots more next lecture. And just to finish off, I want to point out 2 differences between Java and Scheme. One is that everything in Java has a type. And you must declare it. So in Scheme, you used to say, let x 1. And x was assigned to 1, and Scheme didn't care what type x had. But in Java, you have to say, x is an int, give me an int called x, and now that it exists and has a type of integer, I can assign it the number 1. And the second thing you need to know is that Java programs have to be compiled before you can run them. So in Scheme, you just have a Scheme program. And you run it through the evaluator, and it prints your answer. In Java, you have a Java program, which is a .java file. You run it through a program called javac, which stands for Java Compiler. You get out of that class files. And then you can run those class files with what's called a bytecode interpreter by typing Java. And then you get your answer. Any questions about that? Yeah? Half the error checking occurs in each place, really. And so you'll learn a lot during the semester about what kinds of errors are caught at compile time and what kinds can be have to be caught at runtime. Other questions? Yeah. Compiling makes it a lot faster. So your Java programs will run a lot faster than your Scheme programs would because they're closer to the machine. Question back there? So Java doesn't do that usually, although there are apparently some programs you can buy that will convert Java programs all the way to machine language, but that's not usually how it's done. Yeah? The Java virtual machine thing is this, where when you type Java, this is the Java virtual machine running, executing the bytecode in your class files and giving you answers. So for those of you who have heard that term, Java virtual machine, that's what this program is. Yes? I don't know anything about NetBeans. Anyone else? Yes. With your, sorry. Oh, x equal 1? No. No, this is not an object. Java has two types of sort of variables. There are ones that point to objects, and there are ones that are called primitive types. And an int is a primitive type, and so it actually just stores the number 1 in a box instead of creating an object to represent the 1. So this is what it looks like schematically. You have a variable, a box named x, and the 1 is inside the box instead of having a pointer off to some object. Other questions? Yes? Yeah, Java is very close to C. It was sort of built with the same syntax and variable types as C, and then they added new things on top of that and took away some of the old things that were a pain. So pretty much it has the same primitive types, yeah. There's little small differences, though. Anyone else? So if anyone has concurrent enrollment forms you want me to sign, please bring them up, and I'll see you all on Wednesday.